All right, so I got a fun one for you guys today. We're gonna look at two games today that have been written in Bash, and they're specifically meant to be played on your terminal. Now, the cool thing about these games is that I didn't write them. They were actually emailed to me by someone in my audience, which was really cool. He messaged me and he had written these games, he shared them with me, and he was like, hey Dave, I just thought you might like these games, would love to have your opinion on them. I checked them out a bit, I didn't dive too deep into them because I wanted to save it for a video. So I actually responded to him, I said, thanks for reaching out, I checked out both games and they are seriously impressive, they're surprisingly feature complete, and it's super cool. I won't spoil it, but I basically said, would you mind if I made a YouTube video about these? I'd love to show the games off and dive into the code, blah, blah, blah. And he responded to me and he said, hey, thanks for replying. I'd love to see these featured in a video in any form you want to make. So here we go. We're going to dive into these games and kind of look through them and just figure out exactly what's going on and show you guys how to run them. So there you go. I'll have a link in the description, but we have the GitHub repository pulled up right here. Bash Arcade Games by Quazbutt. Go ahead and let me know if I'm pronouncing that correctly. We can actually look into the source code of one of them here and we can see that it's Quazbutt, aka John. So thank you, John, for submitting this, and we're going to go ahead and we're going to look at your code and we're going to run some of this stuff. So yeah, I guess first thing to do, let's go ahead and actually clone this code. So let's copy this link over here and let's head over to my terminal. There we go. The first thing we're going to do is we're actually going to SSH into a Linux machine that I have open. There's a reason for this, and I'll get into that as the video gets going. But let's go ahead. Let's go into my dev folder where I do all my work. And let's go ahead and git clone that link. I just copy and paste that in, and there we go. Now we have Bash Arcade Games. So if we do an ls here, we can see that we have Blaster, we have robot DM, and then we have scores.bla, scores.rdm. So I'm guessing the scores for BLA is the Blaster scores, the scores for RDM is for robot DM. We have a license and we have a README. So the first thing we should do, of course, is go ahead and let's pull open that README so we can use a bat so we get a nice little render of the markdown here. So here we go, Quazbutt's Bash Arcade Games. A collection of arcade games created in Bash script because no one ever told me I shouldn't. Hey, I love that. I am a content creator when it comes to Bash because no one ever told me I shouldn't. So I completely understand that. This is right up my alley. I spent many hours creating and testing these as a challenge and some therapy for bad mental and physical health. Depression and pain sucks. Released to the world to maybe make someone else smile or yell in frustration. Have fun. So pretty cool. Awesome. We have the current lineup. We have Blaster and we have Robot Deathmatch. That's what the DM stands for. Blaster is a vertical scrolling space shooter. Hey, I love those games. One of my favorite games ever is Life Force, which is a Gradius spinoff, aka Salamander, in Japan where it was originally released. Robot Deathmatch, remake of the classic robot chase game, now with shrubs. I think I've seen this classic game before on like a Windows 95 computer, but it's been a long time. Requires some features introduced in Bash v4.2 or thereabouts, if my sources are correct. Testing was done in up-to-date local Debian minimal install and a remote server running Bullseye with Bash 5.x on both. Cool. So I plan on running this on 5.3, so we should be good to go. If you're reading this, it is assumed you know how to make a file executable and run it. Hey, I do that all the time. If you find any bugs, fix them yourself. Listen, I respect that. As of April 2025, there are a couple more in the planning stage. Maybe I'll start them. Maybe I'll finish them. Time will tell. Listen, I understand how that goes. So let's see if this video gives you any sort of inspiration. So let's see what we got here. We have two scripts. We have Blaster and Robot Deathmatch. Now I'm going to do something that I've never done on this channel, but I've gotten a lot of comments from people. I want to talk about good practices because I cloned down these Bash scripts and I'm going to run them on my own computer. Now we are logged into a virtual machine, a Linux virtual machine that I've created specifically for this. However, wouldn't it be nice if we could lock this down a little bit before we run it? So I want to show you guys how you could do this at home if you're running on like a Linux virtual machine and you might have Docker installed. We can create a Docker instance for these, run Ubuntu, and we can actually limit the amount of things that it can do. Here's the thing. I've looked through the source a little bit of these files. There's nothing nefarious in them. I don't think there's anything bad going on here. I don't think this person's trying to hack me. The point is just to show if you were going to run scripts that you weren't sure about, here's a way you could lock them down. I'm not saying it's a perfect solution. It's going to be 100% locked down. Obviously, security comes in layers. But I can just show you a couple ways to limit the amount of exposure these scripts can have in case they were nefarious. So if you're familiar with Docker, you may be able to do something like, let's actually get out of this directory because my prompt is a little bit gnarly. We could do docker run -it for interactive and T to allocate a sudo tty -rm. We'll get rid of the container once we're done running it. The name of the container, Ubuntu in this case, and the command that we run on, bash. So we run this. We get permission denied. On this virtual machine, I have Docker running as root. I know some people don't like that, but this is my virtual machine running inside a zone on an Illumos machine, so I'm not too concerned about it. I'm going to go ahead and sudo this, and we'll run it with root. And there we go. We've created a new Ubuntu virtual machine. I know it's not technically, but we have a Ubuntu machine that's pretty isolated and can't do too many things. Doesn't have access to our underlying file system. But what's something it can do? Well, this thing can actually hit the internet. Let's do something that hits the internet. Let's like look up a DNS record for ysap.sh. We don't have dig installed. Let's use ns lookup on ysap.sh. Let's do host on ysap.sh. I swear I didn't plan this. I figured one of these commands would work. Linux has getend, right? Can you do getend hosts? Why is that? I think host is plural. There we go. Hey, look at that. There's the IPv6 records for my website. I don't know how to get the IPv4 records with getend. I have no idea, but there we go. I'm so dumb. Why didn't I just use ping? We could just like ping Cloudflare or something. Oh, because ping's not installed. Okay, you know what? I swear I planned these videos. So anyways, to prove that we do have internet on here, we could do something like apt update, and you can see that it goes through and updates just fine as proof we were able to get to the internet. Oh man, this is a mess. So one of the simplest things we could do is we could restrict its access to the internet. This is one of the things that I just kind of commit to memory because I find it to be super useful. I've definitely used this at jobs before. -- network, none. This is something super great, super simple. I love it. We run it. We have a brand new instance just like we had before. We're not going to have ns lookup or host or any of that stuff, but we do have getend hosts, ysap.sh. Look at that. It didn't work. That's amazing. Apt update. Look at that. Ignore. It's failing. We can't get to the internet here because we've set it up with network none. What do you do? Is ifconfig? Or no, that's deprecated on Linux, isn't it? What's your guys' ifconfig over on Linux? IP? Dude, I don't know. I don't even know. I got nothing on this minimal install. This is wild. All right, so now that we have that, we can go back into the bash arcade games directory and we can rerun this. The prompt's gonna get a little gnarly here. I'm sorry, it's just kind of how these Docker commands end up running. Sudo docker run, itrm, network none, ubuntu bash. That's really good. We have to actually give it the directory that we want to run. So we can do -v to give a directory. The directory we want to give is, is // so our current directory, colon, and this is where we want to mount it inside the Docker container that we're creating. So we're going to mount that as /games. So there we go. Now we have this Docker container. We are in /, but we should have a new directory called games inside /. So if we cd into games, you can see that. There it is. Now it's mounted as read write. That's great. We could give it a read only flag, but based on these scores here, I'm going to assume that it wants to be able to write to these files. So I don't care. This Docker container can write to these files. That's fine. We can also optionally specify the current working directory. So we could do /games here. You don't need to, but when I do this, now we'll start inside that directory. So hey, look at that. That's pretty simple. So this is a cool way of creating a Docker container that's running base Ubuntu with not many things installed, but it does have the current working directory set to the directory that is our Git repo with these files in it. So with all of that set up, let's go ahead and actually run one of these bad boys. So let's go ahead and run robot deathmatch. So here we go. We can run it and let's see what happens. This is sick. I mean, that's sick, dude. What an animation. That is so cool. I love that. Robot deathmatch. Press any key. Hold on. I'm just going to Control-C that and rerun it because that was awesome. That is so cool. I love that. That is great. So as you can see, we have our high scores up here. Nice job, Poontang. So let's go ahead and press any key. There we go. Cool. So I don't know how to play this game. I'm the yellow guy, and the blue guys are coming towards me. And I'm dead. So let's go ahead and do the right thing here because I don't know how many people watching know how to play that game. Let's go ahead and give it a -H flag so we have the help message. So here we go. Show this page or extended help pages. Fast splash screen. Ooh, saves you 3 seconds of waiting. So I'm guessing that gets rid of the animation that we saw if we run it with -F. Oh yeah, look, it doesn't do that like sleep between each word. That's kind of cool. Let's go ahead and rerun this. -K to reassign keys. That's pretty cool. No color graphics. Hey, that's pretty cool. And show game version. All right, so what we want here is we want the extended help pages. So let's try this. Now this is cool. This is really interesting. Robot deathmatch help system. We have options, how to play, controls, scoring, or quit. So let's go ahead and look at the options. We'll hit O. There we go. It's exactly what we got before with the -H, but look at this. We're still in this little like fake 2E type of thing, which is really cute. I like this. So let's hit H. How to play. Okay, we got a lot here, but let's go ahead and read this. You have been dropped at the center of a strange walled arena. In this arena, you see a number of deadly giant robots waiting. These robots have one mission: kill all humans. As you are the only human around, this is not good for your health. That's so true, dude. The robots are so intent on completing their mission that they will run into each other and blow up as they charge to crush you. Without any type of weapon, this is the only way you can survive, forcing the robots to destroy themselves. When two robots collide, they create a pile of radioactive junk, and when another robot runs into the junk pile, it self-destructs, making the pile even bigger. Junk is deadly to humans, so avoid tripping over it. Okay, so they make junk, which can kill both of us, so that's pretty cool. You will find several tough shrubs growing in the area. The robots can see over the shrubs, but have trouble getting through them. Each time you move, there is a chance that a robot blocked by a shrub will get stuck and blow up, or crush the shrub and keep going. That's clever. Shrubs can be used as shields while planning your next move. Be careful, as running into a shrub will injure you and cost points. While you have no weapons, you do have some defensive tools at your disposal. Your pockets contain a teleporter with a set number of uses and a powerful EMP device with a single charge. The teleporter moves you to a safe, random location across the arena. The device will never drop you on a robot, but you can land next to one. The EMP disables all robots for 3 moves. Both devices reset each level. When all robots have been destroyed, you'll advance to the next level, where an even larger number of robots await. Continue advancing until overwhelmed. There is no end to the horror. Getting a high score is the only thing that matters. Okay, that's pretty awesome. Selectable skill level -S changes the size of your safe zone or how close to the player the robots can spawn at the start of the level. The number of shrubs. Oh, that's cute. Okay, so you can modify the difficulty. That's pretty cool. Let's go and take a look at the controls. Hit C. Bam. Look at this. I like this little help system, man. This is cute. This is pretty neat. Keypad. Move your players 1 step in any direction. The robots will move all step towards you after you move. Watch where you go. Walking into walls or shrubs cost you points. Okay, that's good to know. Space. While waiting, the robots move 1 step towards you. Waiting can be your best defense. Watch and learn how the robots move and crash into each other. Oh, so space is like a blank move. It's basically saying don't move, but let it count as a move. That's pretty cool. R. Repeat next movement and wait until you run into something, get crushed by a robot, or complete the level. Any other key than move or wait will cancel. Oh, okay. Interesting. T. Use the teleporter. Teleporting costs points, but you get bonus points awarded for unused teleports at the end of the level. Oh, okay, cute. And E is the EMP, which we've learned about before. Cool. And we have Q for quitting like a coward. Okay, I respect that. And then we have a whole system for scoring. Oh boy. Okay, that's interesting. Oh, you get higher points for repeating the action. That's something to think about if you're going to points max in this. I think our goal will just be to survive, but if you're going for points, you definitely want to start repeating actions. So Q to quit. Let's go ahead and rerun Robot Deathmatch now that we know some of the basics with it. So we are this little yellow guy. That's awesome. And when we move, I think the DP is they're the robots, and this is the shrub. The green is the shrub. So this robot should move into this shrub if I move up or down or right, basically. And if it moves in that shrub, it should get stuck. Yeah, look, it can't go anywhere. It was just stuck there. So every move, I think there's a chance that it explodes, right? Please explode. Okay, look. So these over here, they crash into each other, and now we have that radioactive waste. Oh, this turned into something. I don't know what that is, but it turned into something. Okay. And if I move up, I'm dead. I can't move anywhere now without dying. So I'm going to have to EMP or have to teleport. I got 5 teleports left. There's 3 junk. There's shrubs. Oh, that's so cool. It shows you. Let's do a T. Let's do teleport. Hey, now I'm here. Okay, this is cool. I would like to be up because I want them to hit the radioactive stuff. That's nothing I can do. Okay, let's do EMP. EMP activated. Robots reset in 3 moves. Okay, so now when I move here, the robot should move again. Nice. I want these robots to crash, so let's go ahead and move up. Okay, nice. We got another crash. Those guys crashed. Okay, we only have 1 robot left. That's huge. I think I win. There we go. Spawning next wave. Okay, well, this is significantly harder. Okay, so we got this guy here. What do we do? I guess we just move and see what happens. I'm going to wait. Okay, so we at least got a crash there. I have run out of safe moves to make, so let's teleport. Cool. Oh, I should have waited. Okay, let's teleport again. There we go. I think I want them to come to me. Oh, there we go. Okay, wow, easy. Okay, I say easy. This level looks impossible. Okay, they can't get me. If I move down, I'm safe. If I move left, I'm safe. I don't have a safe move. So T. Teleport. There we go. So now this cluster, I'm hoping we'll just like run into each other if I move to the right. There we go. Look at that. Look at that. Okay. Not ideal. Let's go ahead and teleport again. So now I can just wait. Look at that. Okay, look at this. Oh my god, we're gonna get a high score. Yo, this is actually weirdly fun. Let's teleport. Okay, let's teleport again. Let's teleport again. I only have 2 teleports left, so yeah, this game definitely gets harder. But now I can just keep waiting. Alright. Oh boy, there's so many. Okay, let's teleport. Not bad, okay. Is the majority of this video just gonna be me playing this game? Because this is like weirdly fun. Oh, you can't just do what I'm doing, because you can really get in trouble if you're not careful. Yeah, you can get in a situation where you just, one's left. You really gotta make sure it dies. There we go, it'll die eventually. Okay, these levels are getting mad hard. At this point, I just want to move just to increase the likelihood of them crashing into each other. Like, I don't even have like a goal in mind. Oh, I wasn't paying attention, and I died. Cool, so we got the game over there. Look at that. All right, so I definitely have some work to do because my score was 865 and the high score is like 21,000. The lowest one is 10,270 here. So I can definitely improve with this game. But yeah, that's Robot Deathmatch. That is pretty sweet. That's a sick game. Now this other one I'm very excited to play because like I said, this is actually one of my favorite like genres of games. All right, so the minimum terminal size is 48 by 64. Yours is 31 by 86. So let's do this. STTY size, 31 and 86. So what we can do is we can shrink it down. I'm gonna do this live on the fly. And then we'll resize it and I'll just eye it up on my OBS and hope that it records properly. 45 by 128. So you won't be able to see this, but let's go ahead and run it. Okay, that's genuinely cool. I don't know how that was done. Hold on. That's incredible. I actually don't know how you achieve that animation. Hold on. I'm getting sidetracked here. Hold on. If I run something like cat proc CPU info, I'm just running something to put something on the screen. It looks like it scrolls away the output and creates like a brand new canvas for you. That's incredible. I don't know how you achieve that. I think there might be an ANSI escape code for scrolling, and it looks like you might just scroll one at a time and then put some sleeps in there or something. If that's what you're doing, yeah, because then it's all gone by the end because it's probably been scrolled out of the viewport. That is such a cool animation, dude. That's sick. I don't know if I've ever seen a tool that does that. It just scrolls out. That is sick. All right, press any key. All right, so you got a sick animation and you used it more than once. Dude, that's awesome. So I run this, I get that sick animation, I hit a key, and then we get an animation. Sick, okay. Oh, okay. All right, I don't even know the controls for this game, but this is awesome. Like, this is legit. Look at that laser. There's an animation on that laser. It's not just on off. Like, there's an animation with it. That is sick. Dude, this is awesome. We do have a little bit of flickering, which is fine. I know you noted that in the email. However, we are over SSH inside a Docker container, so I'm not going to hold it against you. We'll try rerunning this locally to see if that changes anything. But this is awesome, dude. So I'm guessing we have 3 lives at the top and our score is 0010. I don't know how well that's going to show up on the video because it is kind of small. Okay, so if I crash, then we should lose one. Oh, that scrolling thing is sick. We lose one of the lives up here. Okay, that's really cool. And from what I could gather, our health seemed to be at the bottom here. So when I let enemies go by, the yellow bar looked like it took damage. So let's see. If I let enemies go by, there we go. Okay, so we're losing health as enemies go by. This is sick, man. This is awesome. All right, so I've opened up a second terminal here just so we can have the small terminal for testing the game over here in this tab, and then we can have the big terminal over here so you guys can actually read what's going on here. So let's get back to where we were. We had Bash arcade games, and we were in a Docker container here running it. That's all well and good. Yeah, so I just realized I didn't actually do what I did last time, which was Blaster probably has a help message, right? So it looks like the help message does need the larger terminal size, so Blaster -H. Probably don't need to check the terminal size before you give the help message, but not a big deal. So we have the help message here. It might be a little bit hard to read, but it looks largely the same. I can set the game speed. I can set the no graphic. Oh, that's cool. No color and stuff. Let's go ahead and do this. The default game speed is 2. Let's go ahead and set it to 3. And let's say -N for no coloring. All right, invalid input or value out of range. It doesn't like -G3. So we'll look into that. We'll figure that out because it looks like the help message says that should be allowed. Can we give it like -G2? That's considering everything out of range. So that's very interesting. I wonder why that's the case. Yeah, we'll look into that. We'll figure that out. Maybe, oh, you know what? I'm looking at the output. It might have to be right next to it. Maybe that's how. Yeah, okay. So the way his parser works, and technically it does say that with the help message, it wants the number right next to it. So it's not like a GetOps parser or something. It looks like it's its own parsing logic here. But this should increase the game speed. Oh yeah, look, they're flooding down now. This is so cool. So if that works, I should be able to rerun it with what? -N? That's not right. -N. I don't know if you guys can see this. Hopefully it comes in the video. So there should be no color output. Okay, yeah, so same deal. No color. It looks so sick though. That laser's awesome. So same deal, I'm assuming. If I give a -help, we get a whole help thing here with a how to play, and if I do C for controls, might not be readable in the video, but you can see that cursor left to right starts moving your ship in that direction. Press again to stop. Space is the massive laser, precision fire key. Cursor up is the massive layer, rapid fire key. Oh, P pauses. Okay, didn't know that. That might change some things here. So yeah, this is why you always read the help message. So it'll start moving that direction. If I hit it again, it stops. Okay, and then if I hit up, I have a rapid fire laser. Oh, wow. Okay. That's interesting. Yeah, space stops him from moving, but I can just hold down up as I'm moving in a direction. That's pretty cool. Yeah, this is sick. This just looks awesome, man. Nice job. This is incredible. All right, so let's actually look at some code here because I'm very curious on how you did this. Let's open up the let's start with Robot Deathmatch. So here we go. We got the MIT license. Thank you, John. Now with Shrubs, requires Bash version 4.2 or 4.2 or newer. Cool, cool. So simple stuff here, Robot Deathmatch, the version, all that stuff. Yep, this is the score file for it. These are all the constants. These are basically like the sprites that will show up, player, robot. We could change these if we wanted to. We have an associative array called colors, and each one of these will have a color associated with it. Oh, this is interesting. You use \E here, which is the ANSI escape character, but it's stored as a \E. It's not stored as the literal character, so you're probably gonna have to use something like echo -E if I had to guess to actually get that to be rendered like a special character. You could do this notation, which is a $sign and a single quote, and this way the string will actually have the literal ANSI escape in there as opposed to just a \E. Then you can run it through echo normally or printf or whatever, and it will handle it. But there's nothing wrong with this. This totally works. Cool, so we have all the colors here, useful ANSI strings, clear screen, clear down, clear end of line, clear line, cursor on, cursor off. Okay, yeah, see, I'm curious to see how you do this scrolling effect. We're in Robot Deathmatch, there's no scrolling here, but I'm definitely curious to see how you do that because I am genuinely impressed by that. So, okay, we have some functions here. I'm just gonna scroll down and make sure that it's just function declarations. It does look like it's just function declarations. So I'm gonna assume the main method's at the bottom. Let's go to the bottom, and it's not. We have comments at the bottom. Very, very interesting. Let's scroll up and see what we got going on here. All right, so there's a lot of stuff happening here. We don't have a main method or a main function, but we just have code at the bottom of the script. Totally normal, you see this a lot. So the first function you call is check TTY. Let's go ahead and search for that. Check the TTY is at least the minimum size. Look at what you do here. So you run stty size. I have some issues with this one. This one isn't totally portable, but if you're on Linux, this will work just fine. So you read the terminal size. If it's less than 20 and less than 40, what is this? What is this, a terminal for ants? Oh my God, that's a dumb reference. That's cute. Okay, so you save the old settings with stty old, you turn off echo, and you turn off the cursor. So basically we're hiding the cursor, we're making it so when I press a button, it doesn't show up on the screen and there's no blocky cursor. This is totally normal. And then you trap on exit to run when the exit function or when the exit signal is sent. So on exit, very simple. We check if there's a non-zero exit code, like if everything's fine, then that's awesome. We can actually just clear the screen and move on. Otherwise, we just print a new line. So this is cool. So I guess when you're in a debug mode, you won't actually clear the screen, which is nice. Reset the cursor to reset the terminal, reset the cursor to how it was. So this is a very simple function. Makes perfect sense. Let's go back down to where we call that process command line. So I don't love that you're not quoting this. You should quote this variable because then it will prevent it from undergoing word splitting. This will properly turn into every argument exactly as it was passed to your program. I would recommend you do this. I don't see a reason based on my usage of your script why you wouldn't do that. While there are still arguments, you get the first two characters of the argument and then you get all the rest of it. Oh, I see. And then you run it through your own parser. If you wanted to, it's totally up to you. Getops is built into Bash and you could use this to actually parse the arguments for you. You don't have to. Your homegrown solution's fine, but it gets in that weird situation where like -G space 3 didn't work. So you can work around that by doing getops if you wanted to. Nothing inherently wrong with this, just something to keep in mind. And because you're checking the number of arguments is greater than 0, I'm willing to bet that you're going to shift. So if I go to the bottom of this, I should see a shift. There you go. There's your call to shift right here. Of course, makes sense. Makes perfect sense. So you take all the arguments here, you check for the -H, and if the rest of it's ALP, then you know that they wanted the bigger help message, which is cute. We have just some Boolean set here is true, 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 true. Okay, that's exactly how I would program, so that makes perfect sense. And then you do, oh, it looks like basic, like numeric checking. So you're doing a regex match to make sure it's a number, and then if it's less than 5 or greater than 15. So you basically do bounds checking on it. Yeah, that makes perfect sense. Don't use this or you might destroy reality. Start robots 200. Okay, well, we got to try that out, right? I'm going to go ahead and run. I'm not going to bother going into the Docker container. We're just going to run this on my virtual machine and hope that nothing breaks. -Z. So there was a reason why I said don't run this. So I don't know if you'd ever want to play this, but it's fun to watch your algorithm have to process all of it. You can kind of see how it's processing it all one by one. That's a safe location? Yes, safe. Easy. Easiest game of my life, dude. Never played an easier game. Okay, well, that's fun. I'm glad we looked through the source code to find that option. How fun. All right, so the next one we got, init game. Do keyboard setup, set the default values, blah, blah, blah. Makes sense. So then we go through here. It looks like we set some sane defaults. So if the user doesn't supply these, then we go ahead and manually set them. That makes perfect sense. We have the default keys. Oh, that's clever. So like if you want to move north, then it's this A. That's what pressing up on the keyboard will look like if you read the data from it. B is down, D is left, and C is right. Cool. So this is if the user wants to manually set keys, which I think was like a -K argument. So we don't have to worry about that. We actually restrict the size of the max columns. Hey, that makes perfect sense to me. And there's a whole bunch of math here to figure out exactly how we're going to draw things. Yeah, that makes perfect sense to me. So let's go back down. There's got to be a better way to do this. Init level intro and init level start. So I did think that when I watched the intro level, look at this. You can see it generates a whole level, puts the intro on top of it, and then when I do this, it generates a brand new level. So there's an introduction, and then there's the actual level we play, which makes perfect sense. So we init level intro, we init level start. So this is just, init level intro is just for us to look at, which makes perfect sense. Create an associative array to hold object locations. Array key is y, x coordinates, and array element is the object at that location. Array is cleared every level. The player is placed in the center, and the make rows make robot functions populate. Cool. That makes perfect sense to me. So it looks like from this function, init level doesn't have to take an argument. So if it does take an argument, you start with a blank score. Otherwise, we increment the robot count, and then we go to a next level. Okay, this makes sense. So if you call init level without arguments, you're actually moving to the next level. That's how the player goes from level 1 to level 2, level 3 when they beat a level. But if you call it with an argument like start or intro, it's assuming you're starting fresh. That makes perfect sense to me. We got some basic stuff here. Make arena, that's a new function. So in order to make an arena, you clear the screen, you draw the top, you draw the bottom, you draw the right, you draw the left. Okay, so you actually build the whole arena, and you do it by moving the cursor. This is a command to actually move the cursor to whatever $1 is plus 2, and then 1 over here. So this is just hard coded to 1. So if we go back to wherever that is, we can see that we give it the number of rows and the number of columns. So we're basically going to like the first row and doing all the columns, and the first column and doing all the rows, and then doing the end of it. Drawing a square, basically. We place the player, makes perfect sense. You place them right in the middle. And then we have our skills, easy, neutral, and hard. And this is determines how many like shrubs there are and stuff. So this is cute. As you can see, the intro is a little bit special here. When we're doing the intro level, we do some things. We teleport the player away from the message. We display intro message, and then we display the high score. So yeah, it's a little bit special, the intro one, because it calls game intro, which there you go. This is the beautiful ASCII art that we see, which is really, really cool. So it prints it, and then it sleeps 0.5 if it's not the fast intro. So that makes perfect sense. We go through, we print it, and look at this. See this exclamation mark? He's using this as a marker. So there are these exclamation marks here, here, and here. And you can tell that exclamation mark is a special string. It's a sentinel value in this case, which basically is acting as like a scroll stop, which is saying, okay, we're going to draw until we hit the first exclamation mark, and then we are going to sleep. As long as we're not in the fast intro mode, we're going to sleep. We're not going to draw the exclamation mark. We're going to draw robot, sleep. Draw death, sleep. Draw match, sleep twice. So if we run this, you can see that it draws robot, death, match, sleeps twice, and then we get this. So that's what's going on there. That's a pretty clever way of doing it. And then here we go. Here is our main game loop. I don't want to deep dive into all of this code because there's going to be a lot there, but I just want to show like the basics of it. The first thing we do is we handle move player, and then if they were safe or they're waiting, or they're repeating the action, then we can move the robots as long as an EMP has not been active. And then we have this status here. So this game seems to have this internal status variable that keeps track of what state it's in. It's like a statement. It's a game. It's a state machine. So, you know, maybe we're in the oops status, or we're safe, or we're waiting, or we're repeat, cancel, telly, no telly. So this is how communication happens between these two things. So we do all this logic. Like let's say we do move player. We can go here and we can see exactly how we're going to move the player. Like if we're in the repeat mode and they haven't pressed the repeat key. If we're in the repeat mode and they want to stop it. If we want to move the player, we need to figure out exactly where we are moving the player. And look at this. You see during this, status is this, status is this. We're actually setting this here. So this internal state variable is modified in all different functions, but it's a global variable. There's no threads or anything running here, so we don't have to worry about that, which is kind of nice. At any point in the game, we know exactly what's being done, what's handled here, what state we are in. So it's a clever way of handling the situation. I actually really like it. I think it's really elegant. It's elegant because then you get these beautiful case statements like this. Like I can see exactly what we are supposed to do, exactly what we're supposed to print to the user. I know exactly, as the programmer, I know exactly what we're doing at what point. So I think that's pretty cool. That's really clever. Yeah, this is cool code. Now I'm curious to look into the blaster code because there is that scrolling I really want to see. So I'm assuming a lot of the code is going to be very similar. So we have an associative array here. These are just literal strings to bash. We have an associative array here where all the sprites are kind of created here. So that makes perfect sense. We have all the colors for them. Again, these are probably passed to something that can process this \E. And we have, oh wow, a lot of use of associative arrays here. I mean, I love associative arrays, so that makes perfect sense to me. So we have our check TTY function, that makes sense, just like we did before. We have our command line processing function, just like we have before. We have our show help. Oh, this is not something I dove into, so I'm actually curious about this. The show help function does some really interesting things. I'm surprised I didn't dive into this with Robot Deathmatch. The function was called with the section name, extract and print the section using some awk. So that's a very lovely message there. So we're using awk here to actually go into the source of the file itself, $0. This is wild to me. I don't typically write code like this, but I don't fault someone for writing code like this. I think it's actually pretty cool. I like looking at stuff like this. So what's happening here? It's reading its own source code and looking for very specific things. Why is it doing that? Take a look at this. It's looking for this sort of notation, this special notation that means something. It's just a comment to bash. But to us, the programmer, it means something. Now, what does it mean? Let's scroll all the way to the bottom. Remember how I showed the bottom was all these, oh, there's a lot here. Remember how I showed the bottom was all comments? Let's go ahead and look at these comments. Take a look at this. Help text, and then look at this. This is read by the awk command up top and displayed by section name with leading # removed. So this is how he does help, which I think is really clever. This is almost like a compiler hint or something, but obviously it's not a compiled language. So this is just a hint to awk that, hey, here's a new section. So this is nice. He gets to just write a free form help message, and then that code automatically extracts all of the sections. So if you want to update the help message, you don't have to update code with it at the same time. You just go down here and add something. I could add something like, hi, Dave. And then I could run Blaster. Well, I can't run Blaster because I'm going to check that my terminal isn't big enough. Let's go over here and run Blaster with -help. And let's look at the controls. And at the bottom of the controls, you can see, hi, Dave. So that's really nice. I didn't have to modify any code per se. I just modified some comments. So that's clever. So let's go back up here. We have our first run game settings. We have init game. Then we go into our loop where we call game intro, init level, and then we go into our other loop of waiting for key presses, which is cool because this game works differently. Robot Deathmatch is turn-based. It's waiting for us to press a key. This game's slightly differently. This game runs on its own. We push a key when we want to move the ship, but the game's playing itself. So it's slightly different. This thing has to refresh on its own. It has a frames per second type of thing that's outside of our control. But let's go up here. Let's take a look at init game. Because, again, I'm still very curious how you're doing that scrolling thing. All right, so nothing too crazy going on with a init game. Very similar as before. As you can see, we have an easy, neutral, I guess normal is what it's called, and a harder version. So this is just declare some variables that are going to be set for that, which just make the game easier or harder. We have the ability to override the keys, of course, just like we did before. This is interesting. The frame rate, we're using awk to take this number and divide it by 100. I don't know if this, yeah, look at this. We need floating point fractions here. So we don't technically have floating points in Bash. That's kind of why you can do it. You could avoid awk if you know, times it by like 1,000 or 10,000 or something like that, and then put the decimal point back in. But hey, that's totally fine. So cool. We have a init level here, and this is actually how we create like a brand new level. So there's a lot that's going to go into this. I'm not going to go over it all, but there is a function I do want to look at with you guys. Clear the screen with animation. Let's go ahead and look at do wipe. I am genuinely curious. Wait for the keyboard buffer to clear. Okay, well now you've piqued my interest. Let's go ahead and look at key clear. Player might be holding a key, wait until released and keyboard buffer is empty. So that is so interesting. We have a buffer of keys that are being held down. So we want to read with R for raw, so we don't do any backslash mangling, S for hiding the prompt, D, which is the delimiter looked for, in this case, a null byte, dash N1, one character we want to read, and a timeout of 0.2 seconds. So that is wild. There's some wild stuff going on here. So basically we're flushing out standard input in case it's there. We are going to read standard input until there is no more at all. That's what's going on. Basically just completely eliminating the buffer. Now that the buffer is eliminated, we do for I in sequence TTY rows. You don't need to fork out the sequence here. We could clean that up if we wanted to, but let's not even bother with it. So for I and how many rows there are, get BGO and sleep for 0.01. I think this is it. This is absolutely it. So get background object. I'm not sure if that's what it stands for. Clear top line so we can scroll without leaving artifacts. Okay, so it calls an at function. What is the at function? Place the cursor at a row, comma, column. Okay, so this is just going to call this ANSI escape sequence so we can move the cursor around the screen. Clever. Awesome. So now, what was it? At or BGO. There we go, get BGO. Okay, so this is the do wipe function. So we do here, we put a blank string here, we put a blank string here, we draw the play areas, generate a random background object on line 3. Oh, so we just generate a random object here based on a random chance. Oh, wow, random's used in a lot of places. Okay, and we only generate one, and then we loop for all the lines. Okay, I'm actually starting to get this. So this sleep 0.01, fractional sleep might not be supported on your operating system. I find it's pretty ubiquitous, but this may not work on your operating system. But let's go ahead and try this with a smaller one. I'm gonna go over here and rerun it. So there we go. Okay, so that is how it's done. That is what you're doing to scroll the screen. That is so incredibly clever. I love that. That is so clever to me. Yeah, so this is the magic right here. I knew in the back of my mind there was some ANSI escape sequence to do this because I was like, this is some trickery here. So I'm glad that's what it is. I feel vindicated here, but this is really clever, man. I really like this. This is awesome. So we could just change this to like, I don't know, 0.001 and then it'll go really, really fast. I mean, it still has to fork out for each one, but then this will run way, oh yeah, that's like stupidly fast. That's like too fast to even really enjoy it. I think you probably already got the good speed, so I'm not gonna try and improve on perfection here. I'm just trying to show that you could modify this if you wanted to. So we could do like a 0.5, slow it down by half. Yeah, or speed it up. Yeah, I know math. All right, so this is, dude, this is awesome. This is really cool. All right, now there's something I want to do in this video. Because we're running it over SSH, I feel like that's kind of unfair. There could be like flicker and stuff just from having to pass the bytes over the network and stuff because my server somewhere, I'm pointing somewhere over there. Let's go ahead and run this locally on my Mac. This is my local machine. Let's go ahead and let's clone that repo, git clone, paste that in there. And there we go. Now we have the games locally. So let's go ahead and run the blaster game here, and we get some errors. Okay, this is okay. I didn't even think about this, but let's go ahead and look at this code. It's calling bin bash up here. This is going to error on my machine because if you just call bin bash, you're going to get this old version of bash, whereas if you call the version of bash that's in my environment, you'll get 5.3, which is what we want. So I'm just gonna go ahead and change the shebang up here to user bin env bash, and this will fix it on my machine. I prefer this shebang. I have a whole video on why I prefer that shebang, but let's go ahead and just make that change. And now we get this, right? I forgot about this. Let's go over here. Hopefully you guys can see this. I'm on my local Mac, bash arcade games. I won't do much work over here. I'll just run the code over here. So now we're gonna run it locally. Okay, cool. Okay, it seems like there's way less flicker. It seems like it's running a little bit better. There's still some flicker on the bottom, but not a terrible amount. Oh, it just completely froze there. I don't know what happened there. But, okay, so this is what happens if we run it locally. The other one was what? Robot Deathmatch? Oh, we don't need to run on the small terminal. And also when we run it, we're gonna get the same issue. So let's go ahead and change this to user bin env bash. Run Robot Deathmatch, and I don't think this one was even slow to begin with, so yeah, this is what it's like when it runs locally on my machine. Not really much flicker at all, it seems fine. So it's faster locally, but could we make this even faster? The answer is yes. I want to show you guys something else that's cool. This video is just kind of me exploring code and showing you guys cool things on like Linux and stuff, so hopefully you enjoy this. If you do enjoy this, go ahead and hit that subscribe button. Okay, what are you doing? Go ahead and hit that subscribe button. If you want to learn Bash, I have a free course available. Go check it out. I'll link it in the pinned comment. But yeah, if you made it this far, you're awesome. Thank you. I appreciate it. And thank you, John, for submitting this code. This is super cool and letting me make a video about it. So let's go over to Linux. And let's talk about performance. Go back into that directory, bash arcade games here. I talk about this in my videos where I say, you know, oh, you're forking out to an external command. There's a cost when you fork out to an external command. People have asked me, they're like, Dave, how do I know if I'm doing that? My answer is I look at the code and see visually if I see any forking execs, but there are better ways to do this. There are tools that exist to do this. So I will show you them today. Most of you guys are probably running on Linux. It seems like a lot of my audience likes Linux. So I'll show you the Linux tools today. I'm not super well versed in them, but I will show you how to do them. So what we can do here, let's go ahead and run Robot Deathmatch here. We can put something in front of it, strace. I don't know if you guys have ever seen this command. Strace will trace all of the system calls that a program makes. So if I run, let's say, echo hi, just prints to the screen. If I run strace echo hi, gets a lot more stuff here. There's a lot of stuff here, but the important thing here is the syscall that gets fired is the write syscall. It's called with the argument 1, which is the file descriptor for standard out. It's given a buffer of 3 characters, H, I, and a new line, and then it's given a final argument of 3, which is the size of the buffer, how much of that buffer we want to print to the screen. So that's how echo works. The nice thing is we can see how Robot Deathmatch works. This is going to be terrible. Okay, well, this is completely unplayable. So let's go ahead and control C that. That's a nightmare. It's because it's drawing a TUI and trying to output at the same time. So what we can do is we can write that out to a file. So now we don't have to worry about it. -o robot.log. There we go. So if we run this, we can play our game now unimpeded. So I can go ahead and press some keys. I can draw in, I can do all this stuff. It's slower. It's noticeably slower, and that's okay. We're tracing the function. If I control C this, now we'll have a file here, robot.log. And there is a lot here. So if I word count -l robot.log, .log. There we go. There's 9,000 lines there. Okay. That's a lot. We don't need every single system call here. So what we can do is we can limit the strace. Let's go ahead and remove robot.log. We can limit that call to strace to only the exec syscalls. So we can do -e exec ve because that is the specific exec call that bash uses when it creates a new process. So if we run this, now we will only get the exec calls that were made while this program ran. So we can run this a little bit, control C, cat robot.log, and now we have, well, this isn't really useful. We just have a bunch of sig childs, a child process exited. So something was forked, but we're not getting any of the arguments. This might be something you run into when you first try doing this with strace. That's because you only traced the bash command. You didn't trace all the child process. So remember, when an external command is run, we fork and then we exec. When you fork, you create a new process, and that new process is not traced. So we don't actually ever get to see the exec syscall. You need -f to follow the child processes that are created. So -f to follow, -e for the name of the syscall, -o for the file to write to. So let's go ahead and run this now. and let's see if it actually works. So we get a nice little animation. That's great. Let's go ahead and do this. Run around a little bit. Die. There we go. Control C. And oh boy. Okay, that's fun. Let's go ahead and reset the terminal there. Let's go ahead and take a look at robot.log now. So here you go. There's still the sig childs there. So let's cat robot.log. And you can see there's still sig childs, but look at this. Exec VE user bin sleep. So it's called sleep with the argument of 1. So we can see when child processes were ran. So we could like grep through as if we wanted to. We could just like pipe grep for exec VE. And there you go. There are all the external calls that were made while robot deathmatch was running. So we call base name and dir name at the beginning. We call stty a couple different times. We want the size, -g, echo. And then we call sequence a bunch. So we're sequencing numbers, which you can use bash built-ins, but it doesn't look like we're doing it a ton. So it's not a huge deal. We have a couple sleep 0.5s here. That makes perfect sense. Why would there be 4 sleeps? Robot, death, match. Robot, sleep. Death, sleep, match. Sleep, sleep. Remember the exclamation marks from before? So that's what we're seeing here. And then we have the sequences here. There are some other sleeps. This must be once we died or whatever. I didn't actually pay too much attention to that. And then the stty, this resets the terminal back to normal. So there's a lot of nonsense here. This nonsense was just stored from -g. So we stored that in a variable and then reran stty with those arguments there. That's what's going on there. That's all well and good, but that's not what I'm concerned about, okay? I'm more curious about a game that runs at a consistent frame rate. So I'm going to take these arguments and I'm going to paste them over here. So let's go back into that Linux machine, bash arcade games, and let's rerun that. We're going to change robot.log, I know this might be hard to see, to blaster.log, and we're going to run blaster with the strace running. So if we run this, I may have modified the sleep. I don't remember if I modified the sleep there to make it slower. If I did, it's not a huge deal, because once the level loads, then it'll be as fast as it normally would be. Okay, significantly more flashing. It's having a really hard time reading my input. I'm like holding the key down and it doesn't want to move me. Sometimes it does this, sometimes it doesn't. It's a heavyweight thing to trace a process. So same deal, I'm gonna go ahead and run reset here. It's interesting that happens. Let's go ahead and look at blaster.log. So there's a lot more here. Grep exec VE, and there we go. There are all our child processes being ran. As you can see, significantly more. Significantly more. There's our sleep 0.05. That was for the animation line there. We do pipe out to sort. That's interesting. And then here we go. So there are some TRs that happen here, and there are some sequencing that happens here. So we can make this faster by removing these, but I don't want to jump the gun yet. I don't want to do that just yet because I also want to show you there are other ways to get this information. So this is on Linux, but I know a lot of you in the comments have been very curious about Illumos, and some of you have started messing with it. So I want to show you how you can get it in Illumos. This is the fork of OpenSolaris that I'm running here. So I have Illumos. So let's go ahead and check out the code over here. So this is not Linux. It's not a Mac. It's not FreeBSD. It's its own thing. It's Illumos. It's the fork of OpenSolaris. So bash arcade games here, and let's go ahead and run Robot Deathmatch. Look at this. Remember how I told you that stty size is not portable? That was a little bit of a hint of what was to come. It doesn't work the same here. If I do stty size, it doesn't work. If you look up the POSIX spec, size is not an argument you can rely on. Luckily, Bash has this built in, so we don't actually have to worry about that. Let's go ahead and pull up the Robot Deathmatch here. Let's find where we call stty size, and we get it here. We don't actually have to do it that way. We can shop -s check win size. So this will check the window size. It needs to fork a command before the terminal is reset so we can actually get the size. So that's what this little trick is for. It's super unreadable. I'm sorry. We're taking the colon command and putting it in a subshell. This causes it to reread the size. Really dumb, I know. TTY rows equals lines and TTY cols equals columns. There we go. That's how you do it. So this will get it for us. Now if we rerun this, there we go. As you can see, it works. Built into Bash, we don't have to fork out to stty. So that's pretty cool. So this game works. That's really good. For our own sake, let's go ahead and just be good and put that logic in both. So we'll take this, go over here, search for check TTY, find it down here, paste it here, delete that, bam, there we go. Now both should work. Let's just double check our work real quick. I'll go over to this small terminal you guys can barely see. SSH into the Illumos machine, bash arcade games, run blaster, and there we go. It works. That's beautiful. Oh yeah, look at that. Beautiful. That's sick. So we don't have strace on Illumos. except we do, but we don't. We have strace, but it's not the strace you're used to. This is to print streams trace messages. This is specific to the Linux kernel. This is not the strace that you're used to on Linux. We do have dtrace, and we can definitely use dtrace, but in this example, we can use something even simpler. We can use truss. Truss is very similar to strace on Linux. Obviously there's differences between the two, but if you're used to Linux and you have strace, if you're on a Lumos, you want truss. So we can truss a program, we can do like truss echo high, and it's the same deal. It'll print all the syscalls by default, which is super nice. You can see right here. There it is. It's the exact same thing we got on Linux. Slightly different output, but there you go. Oh, look, there's the return code of write too. So we can actually see that write return 3 because it wrote 3 bytes to the screen. That's pretty cool. So very similar here. Truss-o blaster.log dash, instead of E, we can do -T, and this is cool. This takes a family of syscalls. So I can just give it exec, and it will trace all of the exec syscalls, exec VE, exec P, exec, whatever the other ones are. So it'll trace all of them for me. And then, of course, the same deal, -F for follow. We need it to follow into the child process. But now if we run this, it'll work exactly the same. Cool, let's run a little bit, move around, no big deal. We're done, Control-C, and let's take a look at robot.log. Wait, what did I call it? I called it blaster.log and I ran the robot thing. I am an idiot. I don't know why you guys watch me. Let's move blaster.log to robot.log. All right, let's take a look at this. Hey, I like this output. Look at that. We didn't have to grep for anything. We just have exec vex. Okay, cool. And you can see what got ran here. So we have sequences, we have sleeps, we have sequences, and then we have, of course, the interrupt signals that came in. Look at these arguments here, though. As you can see, this isn't the actual argument itself. This is the pointer to where the argument is. This isn't actually the argument itself. So we can tell truss to give us this. You don't have to do this with strace, but with truss, we have to give it -A. And this will go through and actually get the arguments as string formats that we're used to seeing. So same deal. We'll run this a little bit. Control-C, cat, blaster.log, because I didn't change it. And as you can see, there's the arguments here, which is cool. Watch this. Grep for argv:. There we go. Now we can see all of the processes that were fork and exec by our bash script just by using truss on a Lumos. How cool is this? What an easy way to understand exactly what's being forked and what's being exec by our bash script. So, of course, we could clean this up a little bit. So let's go ahead and take a look at some things. So we have, let's get rid of blaster.log and robot.log. And let me, before I do anything, let's turn blaster.log into robot.log so I don't make that same mistake again, because I am just apparently good at making mistakes. So with this beautiful command right here, we can go ahead and take this, copy it over into that small little terminal, and we'll change robot to blaster. We'll go over here, we'll change robot to blaster, and we'll run it. So now we have our blaster script. Look at this. It's not as slow as when you run strace, which is really nice. I like that about this. Pretty fast. Well, I can't get it to go right. So sometimes pretty fast. Control-C. Now we have blaster.log. Let's grep for argv:, and there we go. There are all the things that are fork and exec. Let's do it on the bigger terminal. Grep argv: from blaster.log. There we go. So as you can see, there's some stuff happening. We're running a lot of TRs and a lot of sequences. So TR, we're turning a space into a pipe character, a space into a hyphen, and then we're sequencing up to 3. Let's figure out why we're doing that. First thing we can do is we open up Blaster. Let's do a nice little search for TR space. This will show us every place that TR is being executed. Look at this, shield bar. So we're printfing this, and then we're piping to TR and replacing the spaces with the pipe. So what's happening? What is this syntax? I've talked about the syntax before. I really like this syntax. %*s will take this argument and as a number. So shield is a number, and that's how many times to repeat the second argument to printf. The second argument here is nothing. So it's repeating space. It's repeating a blank line. This printf will create a set of blank spaces, a set of blank characters, a string with blank spaces in it of length shield. That's what's happening here. Now, because there's spaces, we can pipe it to TR, turn the space into pipes, and now we have that many pipe characters. That's great, but we're piping out to TR. So here's a clever workaround for it. Ready for this? I'm going to declare a new string. We'll call it S, and we'll printf the %*s shield, and we'll write that into the S variable. The beautiful thing is printf has this built in, -vs. Instead of printing the screen, it's going to go directly into the S variable. Now that it's there, we can print it to the screen, but we can make some slight modifications to it when we print to the screen. We can echo -n, so there's no new line, the S variable, and let's replace every space with a pipe. There we go. A little bit weird to read. I'll space out a little bit. We're going to print the S variable. We're going to use this notation, // to replace whatever shows up here, which is a space, with a pipe character. And then we can do the exact same thing down here. So let's do that printf again. This time it's shield underbar max minus shield. Okay. And then we replace them with hyphens. So let's go down here, copy that, put that here, replace that with hyphens, get rid of this printf, and this should work. So we can go ahead, save this, and we can test this now. Let's rm blaster.log, and let's rerun blaster with the truss command going. So there you go, press any key, let's get started. And we do have a little bit of flicker still, that's fine. We're not actually trying to fix the flicker, I haven't looked into that specifically, but Control C that. Let's go over here, and let's rerun that grep in blaster.log. And look at that. All the TR commands are gone. We have that sleep from the animation. That's fine. This is where the game starts. There's no more TRs. We have gotten rid of that. The only thing to get rid of now are the sequences. Okay, not a big deal. So let's go ahead and find every place we call SEQ. So it's going to be a lot of them, aren't there? I haven't looked, so I'm genuinely... Oh, that's not that bad. Okay, what, 4 places, 5 places? I don't know. So we can make this a little bit faster. So we have 4i in sequence all the way up to len. So here's the cool thing about the sequence command. If we just say sequence 5, it prints all the way from 1 up to and including 5. So let's turn this into a C style for loop. I'm going to space this out just so I can see it a little bit more easily. We can do this, get rid of the semicolon, put a new line here, easy. And then we can do for I equals 1, because remember it started at 1, I less than or equal to len, we don't need the $, which is nice, I plus plus. There we go. So this accomplishes the same thing, but it's all using bash built-ins, which is super nice. So we can go find some other places. So this happens during the wipe. We could technically clean this up. It's not the biggest deal if we don't, because it's only going to run once, but why not do it for good measure? For I is less than 1, I less than, what variable did I delete? TTY rows. There we go. There we go. And then this one is a for I equals 0 all the way up to 9. So I equals 0. Actually, no, you know, because this is cool because this isn't using any sort of variables. We can just change this for 0.9 in curly braces. There we go. This accomplishes the exact same thing. So there's only one more place where it's being called here. It's being called there. So same thing, 0.9. There we go. So we save that. We go over here. We rm blaster.log, and let's go ahead and rerun blaster. So there we go. Looks good. Press a key. And look at this. Now we're playing. Am I crazy? It actually seems like there's less flicker. Control C that. Go over here. Do a nice little grep. And look at that. Look at that. We just have the sleeps from the animation at the beginning. And then it's done. It's done until all the way when we have to run STTY because I Control C'd it and we're done. There were no fork and execs that happened in between that. So we've eliminated the fork and execs there. That's really cool to see. So I'm not really sure if it sped things up or not, but what we can do is we can back out of here. We're in the bash arcade games directory locally, and we can pull it down from arbiter. So dev bash arcade games, what's the name? Blaster, and pull that locally. So now we have the file locally with our changes. So if we go over here, back out of this, now we're in the same directory. Let's go ahead and run blaster. This is the blaster with no forks and execs. Oh, we didn't change the shebang. So I'm gonna run bash blaster. This will pull it in bash version 5.3 or whatever I have installed. And there we go. All right. I don't think it's any faster. I don't think I made it any faster, but I did eliminate the amount of forks and execs in it. So that's pretty cool. So yeah, hopefully that was fun and interesting for you guys. I really enjoyed that. I get a lot of emails from you guys, which I'm appreciative of. Thank you. I think it's so great. I love people who want to reach out or, you know, talk to me in the Discord. I think that's so great. I get a lot of people sending me stuff, and I can't make a video for everything I get. I'm sorry, but I like to make a video where I can. I think it's really cool to show off things the community has built, and I think it's cool because it helps foster a good community environment. So I appreciate you guys for sending stuff. I definitely want to make more user submitted stuff in the future. I want to show off your creations. I think they're super cool. So thank you, John. Thank you for sending this in. I think it's so cool. Thank you for giving me the okay to make a video about it. I appreciate it. Your code's awesome. I think the game is super fun. Both games are super fun. And I look forward to it if you ever, go on and make any more games. Yeah, let me know, definitely. So yeah, thank you everyone for tuning in. I appreciate it. I'll have the sources linked in the description and everything. And so of course, last but not least, take a look at this. I want to give a shout out to my members over at Patreon, or my patrons over at Patreon. Look at this, 95 active members. You ready for this? I have to scroll the terminal, okay? Which means I'll have to find a different way to lay this out. I might have to actually make it a little bit smaller, or we'll come up with something fun. Maybe like a scrolling marquee or something. I don't know. Oh my God, would that be fun for you guys to make like a video like where I show making a Patreon like shout out thing that scrolls automatically like a credits thing? That could be kind of fun. And then of course I share all this code online. So if other people are content creators and they have patrons over at Patreon, they could use the same thing. I'm just talking out loud. But yeah, thank you so much. Shout out to everyone who has giving me money on Patreon. I love it. You guys don't have to. I don't paywall content. If you support me, it's because you choose to support me. So thank you so much. You guys are awesome. Thank you for the support. I think it's so great. If you want to support me, go take a look at this. There's the link right down there. We could almost hit 100 active members. That's crazy. If you want to support me and you don't want to give me money, I completely get it. I absolutely get it. Just hit that subscribe button. I have about 83,000 subscribers at the time of this recording, and I want to hit 100,000 subscribers this year. So go ahead and hit that button. Thank you so much. Thank you for tuning in. And yeah, that's all I got. See ya. So here we go. Quazbut's Bash Arcade games.